Are you an SRE? A developer? A quality engineer who wants to tackle the challenge of improving reliability in your DevOps? You can enable your DevOps for reliability with Chaos Native. Create your free account at Chaos Native Litmus Cloud.
Hello everyone, welcome to my session, Top New CNCF Projects to Look Out For. It's going to be a great time, I hope, and very much thank you everyone for attending. But let's get straight to it. So, Top New CNCF Projects to Look Out For. You can see the session on the slide there, and that's what we will be going through today. So, before all of my sessions, I like to do a bit of talking about very briefly about what to expect, what is the value that you get by attending this session, this talk. So the kind of like the learning goals for this session as well. So the learning goals here, as well as what I hope that you will be finding out after the session, is I hope that you get inspired. I hope that you encounter new technologies, new projects that you haven't encountered before, and now you can actually start using them either in your hobby projects, either in your work, or just you get to know really cool CNCF projects, and you get to be inspired by them, hopefully to continue forward further. So that's the main goal of this session as well. And I update this session periodically. Anytime new projects pop up that are interesting and whatnot. So keep tuning back if you are interested. So who am I and why am I speaking here to you today? So I'm Annie. Hi, nice to meet you. And I'm a CNCF ambassador and a product marketing manager at Cast AI. Cast AI does Kubernetes cost optimization. So Kubernetes cost optimization by automation. That's where the tongue twister happened. We promise to cut your cloud bill in half, and that's what I do for my day job. But I also do a lot of speaking at conferences, as well as I am a Kubernetes and CNCF meetup co-organizer. I'm also an Azure MVP, as well as an early stage startup coach, as well as a co-host of Cloud Gossip podcast that you can find at cloudgossip.net. So let's get started now that I hope we got all the tongue twisters out of the way, and let's kick off with our main content for today's session. So Cloud Native Computing Foundation, CNCF, that's the topic today essentially, and the projects that come from there. So now let's just briefly look into what is CNCF, aka Cloud Native Computing Foundation. So the goal is, and the mission and what they're doing is building sustainable ecosystems for cloud native software. So it really hosts critical components of the global technology infrastructure. So CNCF is home to, for example, Kubernetes, Prometheus, all of these great projects. And CNCF brings together the world's top developers and users and vendors and runs the largest open source developer conferences. For example, KubeCon plus Cloud Native Con is the long name. And CNCF is part of the non-profit Linux Foundation as well. So I think the impact of Cloud Native is relatively well known, but just as a quick recap. So CNCF does this survey yearly, where they really explore the current landscape of cloud native world, what technologies are people using, what challenges are they facing, and so forth. And this data is from the CNCF 2020 survey. So let's just explore the facts a bit. So the use of containers in production has increased to 92%, up from 84% last year, and up 300% from the first survey in 2016. So containers are really booming, and their Kubernetes use in production has increased to 83% and up from 78% last year. So even though Kubernetes is already a household name, the growth just continues as we go further. So the impact is really huge to the world of software at the moment. Then if we want to now look into what does the landscape actually look like, this is the impact, and what does the landscape look like, what are the different parts of it. So this is what it looks like. And I know it is quite a lot. It's a lot of different areas. One could talk about just as an area of this for like hours, days, and so forth. So it definitely is quite a lot to take in when you first look at this image. I understand, and I totally sympathize with you as well. But if we take in this session, we will take a bit of a closer look into a simplified view of this look and explore a few things in the project landscape, as well as just explore a few of the projects more. So the main goal of this session is also to simplify this view. So if you ever saw this view and you were like, that's quite a lot, now we will take a simplified view and focus on a few aspects of this. So let's get to that then. So there is 3 stages to CNCF projects. So there's the sandbox phase, there's the incubating phase, and then there's the graduated phase. So projects start from the sandbox phase, where they are, starting off, kicking off, they're relatively small, and then they move to the incubating phase, where as they mature, as they get more maintainers and users, all of these things, and then when they get to the graduated phase, they are full-fledged, mature projects, fully recommended for production. And the numbers there indicate roughly, they change quite a lot constantly, so roughly on how many projects are there per category. So there's around 40 to 50 sandbox projects, about 20 to 30 incubating projects, and about 14-ish, a bit more graduated projects. And just to give you an idea how the landscape has really grown, when I started talking about CNCF topics a few years ago, there was only essentially 1 or 2 graduated projects, which was essentially just Kubernetes and maybe Prometheus, and that's it. So the projects keep on maturing, they keep on moving within the limits, so it is constant growth as far as these things go. So if we take another view of how does these different projects and the phases, what they actually mean is, the sandbox phase, the adoption curve is at innovators and techies are using it. And when you get to the incubating phase, then the early adopters and the visionaries are using the project. And then when you get to the graduated phase, that means that you're really used by early majority or late majority already. So you're like a full-fledged thing. I think this is a really helpful view to really understand how does it look like to mature within the CNCF Foundation. So then a bit of expectation management, as well as letting you know which projects I will be covering in this session. So this session is not really built on obviously any scientific method. I don't have a PhD on how to select CNCF projects, nor is it fortune telling. I do not know what will succeed for sure. I do not know what will fail for sure either. But what this is based on is what I'm excited about, what people around me are excited about, and which projects have the best communities. Well, the best is always subjective, but biggest communities, more active communities, a lot of people talking about them and so forth, because obviously for open source projects, these things are great indications of how successful the projects will be, because the more people you have using it, building with it, and so forth is a great indication of passion towards the project as well. And then as an expectation management as well, usually CNCF intro to projects talks are around 30 to 45 minutes. So this is a shorter talk covering many projects. So already by the pure math, I will not be doing a deep dive or even a smallish dive into any of the projects. It will be more of an overview of multiple projects so that you can see what the snapshot of CNCF projects look like, what is probably something maybe that you could use in your projects. So that's the goal here, not to do a deep dive, but I will give resources on how to continue with your deep dive further along. So the projects in this session are Helm, Linkerd, Kata, Flux, Kudo, and Meshery, and a super quick sneak peek project at some point as well. But that's Helm, Linkerd, Kata, Flux, Kudo, and Meshery that we will be going through today. And as I said, I do update the session regularly, so it is constantly in flux, this session. But let's get started with the first project, which is Helm. Now, and I should mention that all the projects, some of them are graduated, some of them are incubating, some of them are sandbox. So even if you are new to the CNCF world, you will get to know about very mature projects. But if you are if you're super deep in the CNCF world, you will find out a few new sandbox projects as well. So there's a bit of everything, a bit of something for everyone. So then Helm, which is the package manager for Kubernetes. So Helm is really the best way to find, share, and use software built for Kubernetes. Helm is a graduated project, so it is very mature. It's one of the earlier ones, very old in a good way as well. So it's fully recommended for production as well. So what is Helm then, as mentioned just now? It's package manager for Kubernetes, so it's essentially homebrew, snack, or chocolatey for Kubernetes. So I think one of the Helm maintainers really said it well. So package management is tooling that enables someone who has a knowledge of an application and a platform to package up an application so that someone else who has neither extensive knowledge of the application or the way that it needs to run on the platform, so that they can use it as well. So that is really the power of package management, and therefore the power of Helm. So what are then the benefits of Helm? If that's what package management is, what are the benefits? Helm helps you manage complexity. So charts describe even the most complex apps, provide repeatable application installation, and serve as a single point of authority. It also has easy updates, so you can take the pain out of updates with an in-place upgrades and custom hooks. Helm also has simple sharing, so charts are easy to version share and host on public or private servers. And you can use Helm to roll back to an older version of a release with ease as well, so it offers really good rollbacks. So what are the principles then of Helm, or the different features, or not features, but principles of Helm? So Helm takes security very seriously. Helm can be already recommended for public deployment. Helm has multiple maintainers and multiple companies backing it. So that comes with, Helm is very mature. It has power user, email list, release candidates, all of these. It supports Mac, Linux, and Windows, and it passed 1 million downloads a month already in 2019, a proper household name. So how is Helm then used? So it's used by using charts, and the prerequisites are to have a Kubernetes cluster, deciding what security configurations to apply to your installation, if any, and installing and configuring Helm. And then the bonus project that I mentioned, which is Artifact Hub, which is a CNCF sandbox project. So it helps you find Helm charts. So the cloud native landscape was in a situation where a lot of the different projects were starting to have their own artifact hubs. So for example, Helm had Helm Hub, but that really makes the user experience very fragmented and very difficult to manage, or kind of, everyone is reinventing the wheel as well. So then Artifact Hub was created with the goal to provide a single experience for consumers so that any project in the CNCF can leverage it. So that's very nice. Sneak peek, super quick mention of a CNCF sandbox project as well. So Helm demo is next up in our agenda. So the demo that I will be doing today is easily deploy complex application, in this case WordPress, to Kubernetes using a Helm chart. So then let's switch over to the side here. Let's choose this terminal, and then let's grab here my notes because I need notes. I make way too many typos if I don't use notes. But that's wonderful and lovely anyhow. So then if we do, and we start with AZ account show to get you understanding what's happening. So then we see that yes, I am logged into Azure and everything is working fine and well. So then if we do kubectl get services, there we can actually, see a bit more info about our cluster. So this shows us that yes, we have an empty Kubernetes cluster running there. So it's empty, so that for this demo you can see that I am indeed doing everything from scratch. So then we can do kubectl get services all namespaces to explore a bit further. And in here we actually now see that the cluster in fact is not completely empty, but for the purposes of this demo it is. So there's a lot of Linkerd stuff running around there, which is useful for our demo that's coming up, which is the Linkerd demo. But for now we're focusing on Helm, and that's why it is empty for this purpose. So if we do Helm list, we can see that no Helm releases in use either, so it is truly in fact empty. So then if we do Helm repo add bitnami, we're adding the bitnami there. So for me it says already exists with the same configuration, skipping it, but that's simply because I've done this before, so that's what's supposed to happen. For you it would do more things. So then we go here and we get Helm search repo WordPress as so, and there we get to some more info eventually when it starts moving forward. Everything is always low with the demo effect anytime that you try to do anything like time sensitive, crucial. So there we go. It took a bit of time, hoping that the demo effect will continue to work, but maybe a bit faster, but let's hope so. So here we see that we have two Helm versions that we could be, two WordPress versions that we could be using, but we will be using the bitnami one because that is newer. So then we can do Helm install bitnami WordPress generate name. So this is when the magic starts to happen, and this portion will take a bit longer than the previous version. So since the previous version took a bit longer, it might take a while, but that's fine. We are ready. We have things to do while we wait. But here we see now a lot of things happened. So we have actually are starting to spring up our WordPress. So now we can actually use the same command that we used previously, which is the kubectl get services, to see if our cluster would not be empty this time. And as you can see, here we go. It is not empty. There's a lot of things happening there. So we can then take the external IP, because we want to access our things as well. So we will go here, we will open a browser. There we go. And then we will get the browser over here. We will open it up there. It will probably take a while for it to still just, sprang up, because it takes a bit of time. But we have stuff to do still while we wait, but we are kind of put it there to load while we do those things. So now we can see that the Kubernetes cluster is no longer empty, and we already have the external IP for our WordPress to use. And now we will get the nice WordPress where we can start our blog or whatever we want to do with the WordPress. But to get inside the WordPress to the admin page, we obviously need a username and password as well. So this is a very neat, easy way to handle this as well. So to get we see the username there already. And then if we want the password, we just take this whole thing and then we put it there, put it in, and then we see, there we go, that's where the password is. Let's already copy paste it to safety, so that when we get this up and running here, that's still loading, then we can get to using that one. So let's see when it opens. We will be ready. Might take a while. Oh, now it's already working. Every time I say that it's gonna work soon, then it magically works. It's wonderful. So then we go to the admin side of things. We put user. We put the password that we just got. We log in, and then we see that there we go. We have our WordPress ready to be used, all nice and good looking there. So that's really great and nice. So I think all in all here, we've done quite a lot of things in a small amount of time. So we've installed WordPress and MariaDB to our Kubernetes cluster, configured WordPress, and stored the admin credentials securely as Kubernetes secrets. Super easy, super quick, and that's truly why I love Helm. Great, done with the first demo, moving on to the next set of things. I sometimes go through a bit of case studies about using Helm, but I think we don't have time to have that today. But you can read more about CNCF's case studies in the CNCF website. There's a lot of good data and a lot of good information there about how these projects are used in by companies in production and so forth. But now we will be moving to the next project, which is Linkerd, which is a service mesh. Linkerd is a very recently graduated project. It used to be incubating for a while, obviously, but now just a month or so ago, Linkerd graduated to the graduated phase. So Linkerd is, as mentioned before, a service mesh. It's ultra-light, ultra-fast, and a security-first service mesh for Kubernetes. It's similar to Istio as far as things go, but it's a bit more streamlined and maybe a bit faster and lighter. And the goal of Linkerd is to reduce mental overhead of having a service mesh to begin with. So what does Linkerd then do? It provides observability. So it's, those service level important metrics, success rates, latencies, all of these. It provides reliability, so retries, timeouts, and so forth. And it provides security as well. So what are the benefits of using Linkerd then? It has a really thriving open source community. It's 100% Apache licensed with a really fast and active community. It has a simple and minimalist design, so no complex APIs or configuration needed. For most applications, Linkerd will just kind of work out of the box. And it has a deep runtime diagnostics, so you can get a comprehensive suite of diagnostics tools, including automatic service dependency maps and live traffic samples. And as mentioned before, it's very fast and very light, it installs in seconds with zero configuration as well. So it installs into a single namespace, and services can be added to the mesh one at a time. And it has actionable service metrics as well. So just mentioned before, success rates, request volume, and latency for every service as well. So what are then the Linkerd principles? How is it built? So it's built to just works. As I mentioned, just works out of the box. Ultralight. It's the lightest service mesh around. It's actually the oldest mesh, the first service mesh around as well. It's super simple, so to reduce operational complexity. And it's security first, and security is not a default. Security is not an extra, it's a default. So Linkerd has its own proxy as well. Envoy is a CNCF proxy project, but this Linkerd uses its own proxy called Linkerd 2 proxy that's specifically built for Linkerd, so that the foundation is more secure and custom. And then we have the second demo of the day, which will be the final demo of the day as well, but continuing with after that with the slide decks and everything. So with the Linkerd demo, it's a bit of a different than the Helm demo app that I showed before. It's a proper enterprise grade app. So it's Linkerd demo app, and I've added Linkerd to it, and then we can see what the app what we can get from the app from there. And quickly before the demo, we can actually go through what is needed to use Linkerd. Just is injecting this, and that's it. So it's super simple. So then the Linkerd demo, which is easy real-time service metrics. And then let's switch over to these demo nodes and let's go to here. So we have another terminal that are color coordinated. So then we take this command, which is kubectl emoji photo port forward, so that we can actually get our demo app working. So we'll grab the here, move on to here where our amazing WordPress is still running very well. It's handling a connection, and then we see that, yes, there we have, which is this app. Let's make it a bit bigger so that we can see a bit better maybe. So it's emoji vote. It's a very simple as far as the functionality goes. So you have all of these emojis. We have to decide on which emoji to vote for. We vote for the embarrassed or smiley or so forth. Then we can pick another one. We can vote for the masked one, which is our favorite. We can vote for the monkey one, so forth. It has also built in, you know, like 401, so that you can see this. But then we actually, if we click view the leaderboard, we can see that there's quite a lot more votes cast than our simple votes there. Quite a lot of voting happening. So that's the bots voting on the background. So for this app, we're gonna see what are they doing and what's happening on that side. So then let's go to this, for example, and then let's open there. So to see what the bots are doing and what's happening in the background, we can see, we can put Linkerd emoji with the top deploy, and now we see a lot of action happening, a lot of get data that we are getting, and then we can actually go to another terminal to get things up and running here with tap deploy on the other side, and there we can see what's happening inside a single bot. So it's a bit of more detailed view. So then we see all of these things, and then we go to here and we put Linkerd dashboard in. We will get even more info here. So then we have that opening up in our default browser. Let's just click at this and make this a bit bigger so that we are not disrupted by all the background things happening. So in here we see then a graphical way to explore this data. So then if we want to see, for example, the same data that I showed before, we go to here, we click on the emoji photo, and we click on start. And there we see the same data, but maybe in a, to me at least, in a bit of it's a nice format to read through. And then if we go to namespaces and we click on emoji photo, for example, we can see the structure that we had before. You see deployments, pods, replica sets, all of these things. And then if we go to click here, we see even more visual things brought to you by Prometheus, actually. It's gonna take a while for it to load, but we will get there, no worries. Loading. So now we're starting to see that we see global success rate, global request volume, deployments, success rates, request volume, and all of these nice things in a really visual, nice format. So that's how easy and nice Linkerd is and works. So then we can get back to the slide set once again. There we go. So that was the Linkerd demo. So then we're going to move on to KEDA, which is Kubernetes Event-Driven Autoscaling. So KEDA is incubating project, a very recently incubating project actually. 1 or 2 months ago it went from sandbox to incubating. So what is KEDA then? So KEDA really focuses on serverless. So focus on your code, event-driven code and scaling, on-demand compute, pay-per-use and these things. So how KEDA maintainers view serverless is the automation glue between services, rapid APIs, event stream and queue processing. So really, default Kubernetes scaling is not really well suited for event-driven applications, and Kubernetes is more for resource-based scaling, so CPU and memory. So then Kata provides event-driven scale controlling that can run inside any cluster, so that it can monitor the rate of the events to preemptively act before a CPU is even affected. So that's where the benefit and the power lies with Kata. So you can install it into a new or existing clusters, and it has extensible and pluggable scalers to grab metrics from multiple sources as well. So what are the Kata principles then? It's to not rebuild anything that Kubernetes offers out of the box. It is single purpose, simple, non-intrusive, and it works with any container and any workload. And then there are 2 public case studies for Kata, which is Alibaba Cloud and Cast AI. So Cast AI, the company that I work for, is a proud end user of Kata as well. Then moving on to another project, there's so many to cover through, which is Flux, which is the GitOps family of projects, is the tagline here. So Flux is an incubating project as well as is Kata as well. So let's go. So what is Flux? Really briefly, so the Flux is incubating project, but it's actually relatively mature for an incubating project. It's already recommended by the CNCF technology radar as the technology of choice to be used for GitOps. So the Flux has a lot of the project has a lot of end users. So what is GitOps in this context? So you have all of these CLI tools. So kubectl apply, kubectl set image, Helm upgrade, kubectl upgrade, so forth. So that it replaces all of those with the most widely known CLI tool, Git. So with the Git push tool. So really, it really goes into, instead of changing the state of your cluster with multiple things, you can use one command. So you can modify something, push it to a Git repository, and therefore it ends up in the cluster as well. So this can be anything from namespace and so forth. Git also gives you a nice history of what has happened to your cluster in the past as well. So GitOps provides a really nice one model for making infrastructure apps and Kubernetes add-on changes. So you have consistent end-to-end workflow across your entire organization. So really what this means in a nutshell is that you have an easy snapshot of your cluster that you can restore to. So if anything happens. So if you lose your cluster, you just block your new cluster to Flux and you restore everything. So everything meaning that it doesn't obviously include no stateful sets or databases. So everything that was in the Kubernetes memory essentially. So to simplify things, it's a desired state that stays saved in Git, and it's not the actual thing, but the desired state. So it's kind of like a save point that you can restore back to. So why is Flux so great for GitOps then? Flux project aims to really provide a complete continuous delivery platform on top of Kubernetes, supporting all the common practices and tooling in the field, for example, customize, Helm, and metrics with Prometheus, and so on. So that's Flux in a nutshell. So what are the Flux practices and benefits then? So Flux has defined GitOps practices as describe your system declaratively, keep configuration under source control, use software agents to reconcile and ensure correctness, and alert for drift as well. And really the benefits are collaboration on infra, access control, auditable history, drift correction, and clear boundaries between dev team and Kubernetes as well. So then moving on to CUDA, which is the Kubernetes Universal Declarative Operator. So CUDA is a sandbox project. So it's not as mature as the previous projects, but still very cool and nice. So CUDA really goes into the issue of stateless versus stateful apps. So if all apps were stateless, everything would be super simple, but not all apps are. So stateful apps need logic, specific knowledge to run a certain application. So Kafka might differ from Cassandra and so forth. And Kubernetes has been very focused on stateless, and stateful apps do not really like it. So Kubernetes has created stateful sets to mitigate this problem, but it does not really solve the fundamental issue with the solution, and the solution here is operators. So what are operators then? Operator manages and monitors the lifecycle. It takes a lot of custom knowledge to build one. So each operator is unique and purpose-built for each application. So often operator framework or cube builder is used to build an operator. But building operators really requires deep expertise and may require thousands of lines of code. So substantial engineering resource is needed. So this is where CUDA comes in. So rather than using a custom operator, CUDA provides a universal operator with the concept of plans built in. So what are the benefits of CUDA then? So CUDA can create operators without needing deep knowledge of a Kubernetes or coding, just by defining the lifecycle stages. You can just use Kubernetes API, so it's a lot easier to learn. And it has Kubernetes native management, aka using kubectl and other familiar tools as well. So it's simple to use as well. A really cool sandbox project. Then kicking off with the last project for today, which is Meshery, the service mesh management plane. It's a sandbox project, super new. It got accepted to CNCF as a project, let's say a few weeks ago. It's a super new project. But it's actually very popular already. It's the most popular project for mentorships in the Linux Foundation already. And it has already 15 maintainers and 300 plus contributors, so very, very fast growing. So service mesh management plane is the name of the game here. So mesh is that service mesh management plane. So if you end up in a situation where you have to use multiple, or you need to use multiple service meshes, the reasons might be legacy, personal preference of team members. So you end up in a situation where you have more than one type of service mesh running inside one cluster. So for example, if Linkerd and Istio are in the same cluster, things might get a bit difficult. So this is where Meshery comes in. So it provides service mesh performance by being the management plane. So usually service mesh compromises of control plane and data plane, and this adds kind of like the third plane, which is the management plane that manages all the different service meshes. So it provides federation, integrates with backend systems, may help perform chaos engineering, deeper insight into the performance, really a long list of things that it can do. So it is quite wonderful. So Meshery supports over 10 different service meshes. It provides multi-mesh management, so lifecycle, workload, performance, configuration patterns and practices, chaos and filters as well. So Meshery is about halfway to complete architecture, so it's not at full version 1 yet, but getting there. And I mentioned very popular for being such an early stage project in CNCF. So starting to wrap things up, I still have some of the learn more resources coming up and all of these things, but wrapping up. So we went through CNCF overview, we went through multiple projects. So we went through Helm, Linkerd, CUDA, Flux, Kata, Meshery, plus the bonus project of Artifact Hub. And then a few resources here. So you have, I recommended checking out the CNCF survey. You can check out all the project sites from Helm, Linkerd, CUDA, Kata, Meshery, all of them. You can check out the case studies area of CNCF to learn more how these projects are being implemented in real life. The CNCF End User Technology Radar is really cool. I recommend checking that out. And the Kubernetes or the CNCF Technical Oversight Committee does this kind of their predictions for the future of cloud native tech at every KubeCon essentially. So that's a super nice, very enjoyable session. Highly recommend checking it out. Tech World with Nana has a lot of good content for if you are starting your cloud native journey on how to, for example, use these tools step by step. CNCF YouTube has a lot of great content. For example, all of the maintainers usually have a session there on like a more of a deep dive compared to my session on all the projects, so you can learn more there. So I'll be adding this slide deck to my GitHub as well, so you can find that at github.com/Annie Talvasto. And then if you're interested in finding more about Cast AI, which is the company that I work for, where we do Kubernetes cost optimization, where we're really good at that, you can go to castai.com/Annie, and if you want to leave your email there, and we will email you some things. We will also give you a $25 gift card to the CNCF store, so you can use that to get your Kubernetes plushies, Kubernetes t-shirts, all of these fun things. So that's, if you want that, you can do that. And then a few recommendations still. So I did my one podcast episode on adventures in open source with Tom Kirkhope. So Tom is the maintainer of Kata. So he really went in a very candid manner, talked about how does it feel to, and how does it work to maintain an open source project for CNCF, how does it work, how does he split his time as a personal life to work, to maintaining projects, and all of these things. Really, really wonderful insight into the mind of a maintainer. And then if you're interested in starting to contribute to CNCF projects, you can check out, there's a lot of good resources on that. And for example, a keynote getting started in the Kubernetes community from a few years back in KubeCon is really great on how to get started if you want to contribute, if you want to start doing meetups and all of these things. I recommend checking these things out as well. So the one thing I hope that everyone, as mentioned in the beginning, is that everyone takes away from this is inspiration and so forth. So I hope everyone has had a lovely time and learned something new. And if you have any questions later, I'm super happy to always answer them in Twitter, for example. So you can find me there at Annie Talvasto. So you can reach out to me, ask those burning questions, and I'm super happy to help on there as well. So I hope everyone has a absolutely wonderful conference, an absolutely wonderful time, and a great week. And talk to you in Twitter or some places as well. Thank you, everyone.